Right, finding domains of functions. Okay, so I'm just going to read this. When a function f whose inputs and outputs are real numbers is given by a formula, like an equation, a function, the domain is understood to be the set of all inputs for which the expression is defined as a real number. Now, we'll come back to that. Okay. When an input results in an expression that is not defined as a real number, we say that the function value does not exist and that the number being substituted is not in the domain of the function. What we're trying to say here is there's certain values of x we can use in equations. Sometimes you can use anything, sometimes there's some restrictions on what you can use. It depends on the function, on the equation. Let's have a look at some. Okay, so let's have a look at this. Now, there's two situations really that you're going to come across in college algebra, and it's this. Rational functions. Now remember, we cannot divide by 0. So anything that makes the denominator 0 cannot be allowed. Okay. Also remember, there's certain things we can't square root. That's why the first two examples they'll have like either rational or square roots. Remember, we can't square root negatives. Again, anything that makes the thing inside the square root negative, we can't have. Let's have a look through some of this. So what we're saying here is okay. Here we go. If I put x equals 1 into here, 1 take away 3 is -2, so I'm going to get basically -1/2. I get an answer. That's fine, okay? Now, if I put 3 into here, well, 3 take away 3 is 0. Look, I can't have that. So basically, x cannot be 3, okay? Now, we did some of that in intermediate algebra. If you've done an 055 before, that was basically the answer. Okay, what we're saying here is we cannot have 3. Okay, and I suppose really how we're supposed to write it is this. Okay, so we can use any number but 3. So in interval notation, it's this: from -∞ to 3. Remember, we can't have 3, and then also from 3 to infinity. Okay, that really, so that there, like set notation, okay, is the same as that, but in interval notation, which of course we'd like you to use. Okay, so that means x cannot be 3 because I can't have 0. Okay, let's have a look at this. How about square root 1? 16. Yes, I can square root 16. I mean, it's down here. You can see some of the answers are all here. Okay, square root 16 is 4 plus 5 will end up with 9. So it's all down there. Okay, and that's fine. Okay. But if I try -7, well, I can't square root -7. Okay, so I can't have -7. Okay, basically I can't have negative numbers for this situation. Okay, because I can't square root negatives. Let's have a look at some more. Right, okay, so if I look at this one, here's what you really want to do. Look at that. As soon as you see a rational, basically you're doing this to the denominator. That cannot be 0. This cannot be 0. And then just solve it like you would do for 0. Okay, put it equal to 0 and solve. But remember, that's what it can't be. So can you see? X cannot be 7. X cannot be 7. Okay, so it's down here as set notation. There it is. Okay, but as interval notation, here we go. There we go. Can't be 7. So from -∞ to 7, then 7 to +∞. Okay, that's how we write it in interval notation. Now, something like b, a bit more complicated, because when we set the denominator equal to 0, well, that's a trinomial and we have to factor it. So I'm going to do this. Two numbers make -3 when you multiply, +2 when you add. Okay, remember, equal to 0 or not equal to 0, depending on how you want to write it. And this is going to be, is this x plus 3, excuse the space, x minus 1. Okay, that'll factor into that. So you cannot have a -3, see that there? You cannot have a +1 because it'll make it 0, so you can't have these. Now this is going to be a bit complicated. So there it is, there's the set, what I just said, right there, okay? Can't be -3, can't be 1. How do you write that in interval notation? Well, here it is. So this time you've got 2 places it can't be. So if you go back to this one above here, remember just one number it can't be, the 7. So I have to split it like that. Now with 2 numbers, so look at this. It can't be the -3 and it can't be the 1. So from -∞ to -3, then -3 to the +1, and the +1 to the infinity. It looks a bit of a kind of mouthful, so you'd rather just write can't be -3, can't be 1, but that's the interval notation. Okay. Now remember, We're looking for things that we can't have. Okay, so again, we can't have zeros as denominators. We can't square root negatives. Look at this. Well, I can't see any denominators or square roots here. You can put whatever you want into that. Think about it. You can cube any number. You can put any number in an absolute. There's nothing restricting you. So remember, a lot of equations are just, look at this for C down here, negative infinity to positive infinity, all real numbers. There's nothing stopping you from putting whatever you want in that equation. There's no square roots. There's no denominators. Look at point D, okay, question D here. That's a cube root. You can cube root anything. Remember, you can cube root negative 8. It's 2, negative 2. You can cube root positive 8. That's positive 2. So you can cube root negatives. So again, there's nothing from stopping you actually doing the cube root of something. Again, look at this down here. It's all real numbers. Now, square roots. I'll deal with square roots because square root, again, remember from the previous, what we did, where is it? Here, okay. So remember, we can't, there we go, we can't square root certain numbers. But let's make it a little more complicated. Some square roots. Okay, so remember, here's how you do it. Now, we did a little bit of this in 055 visually. We'll do some visuals in a bit. So remember, you cannot square root negatives, which means anything inside that square root must be greater than or equal to 0. Anything in that square root must be greater than or equal to 0. You can square root 0. Anything greater than or equal to 0. Anything inside the square root, that is what you do. So if you go back to look at these, remember that's how it worked out the denominators cannot equal 0. With square roots, they must be greater than or equal to 0. Well, look at this, okay? If I add a 4 to both sides here, then that's the answer. In interval notation, I've got a cat, hang on. In interval notation, that is from 4 to infinity. There you go, that's the interval notation. From 4 to infinity, including the 4, bracket. This one, if I take away 2 from both sides, in other words, negative 2 to infinity. Now, if you need to check these, have a look. Okay, so 4. If I put 4 there, 4 take away 4, that's okay. I can square root 0. And anything bigger, 5 take away 4 is 1. I can square root 1. 6 take away 4 is 2. 7 take away 4. 8 take away 4. All numbers bigger than 4 will make that okay. Okay. So again, all numbers bigger than negative 2. If I put a negative 2 right here, negative 2 plus 2, that's okay. Put negative 1 plus 2. 1, that's okay. If I put negative 3 there, then negative 3 plus 2 is negative 1, and I can't square root it. Okay, so again, just check the numbers. How about this one? 2x minus 6 must be greater than or equal to 0. If I add a 6 to both sides, I get that. Divide by 2, I get that. Okay, the answer is, in interval notation, 3 to infinity. Okay, trick 1 coming up. Right, now you're going to go back and test the numbers. Definitely for this last one, I'm going to have to test the numbers. Here we go. 8 minus 2x. Anything inside the square root must be bigger than or equal to 0. Let's take away 8 from both sides. I'll get that, won't I? Yeah? Okay, now remember, what do we do here? If I have to divide by negative 2, what we do here, that switches. Negative 8 divided by negative 2 is still 4. So there is my answer. So now the x's have to be less than 4. Now interval notation is this. Okay, here it is. From negative infinity up to 4. Okay, other way around this time. Bracket, equal sign. Now let's just check. So everything has to be less than 4. Okay, let's try 3. What's 2 times 3? That's 6. 8 take away 6 is 2. That's okay, I can square root it. It's positive. Try something that's not less than 4. How about 5? Look, here. 2 times 5 is 10. 8 take away 10 is negative 2. I can't square root it. I'm just kind of proving you why this works, okay? So watch those, all right? It's kind of the x kind of back to front with a number, and it's negative. That's the big thing. It's negative, okay? Okay, so that is you doing domains of square roots in interval notation, okay?